All right, guys. Uh, you are welcome to today's tutorial. And thanks for joining us. So today we'll be looking at another interesting topic, which is one of the most fundamental topics in mathematics. We'll look at it today. So, okay. So indices. This is a very interesting topic in mathematics. So we'll be looking at it today. Okay. So when we say indices or exponential function, either you call it indices or you call it exponential function. Now, when you hear exponential function, what will simply come to your mind is you have a whatever, it can be a variable, it can be whatever, it can be a number, or let's just say something carrying something. For example, you can say A, then is having an exponent, that is, or is having a power. Let's say it's. So now, when you see something in this form, this is indices, okay? This is an exponential function. And if you check this very, very well, you'll discover that this one, the A, is called the base, okay? The X is called the power, okay? So we can see numbers are in exponential function. There are some numbers that are in exponential function. For example, you see 5 is an exponential function. That's 5 raised to the power of 1. 25 is an exponential function. Is an exponential function which is 5 raised to the power of 2. 125 is the same as 5 raised to the power of 3. So when you express number like 5 as 5 raised to the power of 1, and 25 as 5 raised to the power of 2, and 125 as 5 raised to the power of 3. So this is simply called exponential function. And also, this is very the same as you have been saying you have only one 5. And this is the same as you say 5 times 5. This 5 times 5. And this is the same as 5 times 5 times 5. So not only you don't only express it in 5 only, it can be in any number. For example, I can say 2 raised to the power of 1, which is 2. Then 2 raised to the power of 2 can also be 2 times 2, which is 4. And 2 raised to the power of 3, which is the same as 2 times 2 times 2, which is 8. And 2 raised to the power of 4, which is 2 times 2 times 2 times 2, which is equals to 16. All right, note. We need to note this before we move on. So notice that 2 raised to the power of 3 is not the same as 2 times 3, okay? Now, what do I mean? What I mean is that when you have 2 raised to the power of 3, 2 raised to the power of 3, as I've stated here, 2 raised to the power of 3 is 2 in 3 places. That is 2 times 2 times 2, 2 multiplying 2, and 2 multiplying 2, that's 4. 4 multiplying 2, that is 8. That's what we have. Then that's for 2 raised to the power of 3. Then we also have the other 2 times 3 is 6. So 2 raised to the power of 3 is 8, and 2 raised to the power of 2 times 2, 2 times 3 is what is 6. So we see that they are not the same thing. In case you see something like this, don't mistake 2 raised to the power of 3 to be 6. It's not the same thing. Okay, let's move to the laws of indices. Very important. Let's move to laws of indices. Okay, basically we have like seven laws. So we are going to look at them. 7 laws. So laws of indices. So we want to quickly look at them. So the first law is what we call multiplication law, and this is how it works. So when you have a raised to the power of x multiplied by a raised to the power of y. Okay, so this is an indices function. This is an exponential function. So when you have something in this one, what you simply do is that if the two functions multiplying each other have the same base, okay, like this is a and this is also a. So you pick one of the a, then what you do is that you add the powers together. So when you have a raised to the power of x multiplied by a raised to the power of y, so it's going to be a raised to the power of x plus y. That is the first law. Then the second law is the second law. The second law is division law, which is a raised to the power of x divided by a raised to the power of y, which is the same as a raised to the power of x divided by a raised to the power of y. So you can write it like this, or you can write it like this. It's the same thing. So when you have something in this form, it's the same as you saying a raised to the power of x minus y. So that's the second law. Then the third law is uh, uh, okay. So when you have a raised to the power of x, then raised to the power of y also. So this is the same as you saying e raised to the power of x y, or you can say e raised to the power of x times y, which is the same as e raised to the power of x y. So that is that one. Then number four, the fourth law. Please take note of all these laws. We are going to be using it. When you have e raised to the power of zero or anything raised to the power of zero, the answer is simply one. So anything that is raised to the power of zero, it can be 1,000 raised to the power of zero. It can be 200 raised to the power of zero. It can be 500 raised to the power of zero. It can be anything raised to the power of zero. The answer is simply one. Then also when you have then the fifth law, you have e raised to the power of x divided by b raised to the power of x. So this is, you notice that here we have different base but the same power. So what you do is that you try to pick, you try to, just pick, since they have the same power, so you pick one of the power and put it. Okay, so we are here. Then when you have, okay, then you have that's b raised to the power of x. So it's going to give you a over b raised to the power of x. Or also this law can also be for multiplication too. It can also be ax times b raised to the power of x. So which is going to be a times x raised to the power of x, which is the same as ab raised to the power of x. Then the sixth law is, let's say you have a raised to the power of x equals to a raised to the power of y. So it's the same as when you have x is equals to y. Then let's go to the seventh law. So for the seventh law is, for example, if you have, let's say, a raised to the power of 1 over x is the same as x root of a. Okay, so uh, then also if you have, let's say you have a raised to the power of x over y, so it can be to be y root of a raised to the power of x. So it's very simple and easy. Then finally, then when you have the negative, let's say you have a raised to the power of minus whatever, it can be minus x is the same as a raised to the power of 1 over a raised to the power of x. Then also if you also have, let's say you have a raised to the power of minus x over y. First of all, it's going to be this minus as a power will be 1 over, is an inverse, so inverse x over y. Then also it will now give you 1 over, we make this denominator here, we make it as a root, then we have indices perfect. So these are basically the laws of indices. Okay, let's take some examples. Let's apply this and let's see how it works. So let's see that, let's take our first example. let's say that you have 0.027 raised to the power of -1/3. If you have this kind of problem, or you have to solve this kind of problem, so what you simply do is that you have to convert this decimal point. You have to convert it into fraction. So if you convert it to fraction, just move this point 1, 2, 3. So 3 times you have 27 divided by 1000. Then everything raised to the power of -1/3. Then now you can express this in an index form. So with the secret of indices is that when you are given a particular problem, what you try to do is that you try to express it in index form. So please take note. If you are given any problem to solve, first thing you do is that so far as an index is an exponential function problem, you try to express it in index form. So by doing that, it will be easy for you to understand. You'll be able to solve it. So 27 will be 3 raised to the power of 3, and 1000 will be 10 raised to the power of 3. Then everything into -1/3. So don't forget that law. So the law whereby you have the same power but different base, so you simply pick one of the power, then multiply by, you're already having 1/3 here, so -1/3. So which is going to be 3/10. Then this will cancel this, then you have -1/3. So you don't forget this law also, inverse law. So which is going to be 1/3/10. So which is going to give you 1 divided by 3/10, which is 1 multiplied by 10/3. So you reciprocate it, then you have 10 divided by 3. So you can either leave the answer like this, or you break it down. So it's going to be 3 whole number 1/3. So that is the solution to the problem. Let's take another example. Let's say that you have 125 into -1/3, then times 64 into 1/3, then times 81 raised to the power of 0. If you have something like this, now I told you that anytime you have indices for an exponential function problem or indices problem, the first thing you do is that you try to express all the numbers you are given in index form. And you make sure that somehow, if it's possible, you express all of these numbers in the same base. Okay, like 125 now, you can express it as 5 raised to the power of 3. Then into -1/3. Then times 64 can be either 4 raised to the power of 3 raised to the into 1/3. Then times 81. 81 is 81 raised to the power of 0. We already know the law. That's 1. Okay, then you continue by saying 5. So you just take out that 3 multiplied by -1/3, then times 4 raised to the power of 3 times 1/3. So which is equals to, now this will cancel this, so it's going to be 5 raised to the power of -1 times 4 raised to the power of 1. So which is, so this is 5 raised to the power of -1, is going to be 1/5 times 4. Then what do you have? We're going to have 4/5. That is your answer. Okay, let's go ahead. Let's solve more plenty examples. Let's solve plenty examples. Okay. Now let's see that you have another problem. So this problem is you have 6 to 5 raised to the power of 3/8, then times 5 raised to the power of 1/2, then divided by 25. All right. So I told you that the first thing you do if you are solving this kind of problem is that you try to express all of this number in index form. So let's express everything we have in index form. Like 625 is the same as 5 raised to the power of 4. Okay, then into, that's 3 over 8 multiplied by 5 raised to the power of 1 over 2, then divided by 5 raised to the power of 2. Then you can now have that 5 raised to the power of 4 times 3 over 8 times 5 raised to the power of 1 over 2 divided by divided by 5 raised to the power of 2. Then this will give you 5 raised to the power of, so 4 here 1, 4 here 2. So you are going to have 3 over 2, then times 5 raised to the power of 1 over 2, then divided by 5 raised to the power of 2. So this is, you can simply use the law 1, that first law, multiplication law. So you pick one of the base, then you say 3 over 2 plus 1 over 2, of course, then divided by 5 raised to the power of 2. So this is going to be 5 raised to the power of 4 over 2 divided by 5 raised to the power of 2. Then what is 4 raised to the power of 2? That is 4 raised to the power of 2 is 4 divided by 2 is 3, then divided by 5 raised to the power of 2. So which is going to be 5 raised to the power of 2 is 25. 25 divided by 25 is 1. Okay, let's go further. Let's take another example. Okay, so let's say you have 4, then the square root of 3 multiplied by 16 raised to the power of square root of 3 divided by 4, 3 square root of 3 minus 1. In order to solve this problem, we have to express all of these things in the same base. So for example, this is 4 raised to the power of 3, the square root of 3. You can leave it like that. Then 16 can be 4 raised to the power of 2, then with 3, because 4 raised to the power of 2 is 16, then divided by 4 raised to the power of 3 root 3 minus 1, which is going to be, here you're going to have 4 root 3 plus 2 root 3. Yes, we use the first law, that's the multiplication law. We have 4 as the base. So you pick one of the base and you add the powers together, divided by 4 raised to the power of 3 root 3 minus 1. Now look at this again. We have 4 as the base and 4 as the base, then division. So all these, I will pick one of it and we subtract the power from each other. So 4 square root of 3 plus 2 raised to the power of 3 minus 3 raised to the power of 3 minus 1. We're going to put this thing in brackets because we know multiplication and subtraction as a way of affecting our answer. We have 3 plus 2 root 3, then minus 3 root 3 plus 1. Okay, so this and this will give you, so this is root 3 and this is 2 root 3. So it's going to be 3 root 3, then minus 3 root 3, then plus 1. So 3 minus 3 root 3 will also give you 0. So you are going to be left with 4 raised to the power of 1, which is going to be 4. That is your answer. Okay, I hope you all are getting me. All right, let's take another example. Okay, now let's say that we have another one. We have 27 raised to the power of 2 over 3, then multiply by 32 raised to the power of minus 2 over 5, then divided by 64, then raised to the power of minus 1 over 2. Okay, for something like this, what we'll do is that let's express everything in index form. So 27 is the same as 3 raised to the power of 3, then multiply by 2 over 3, then times 32 is 2 raised to the power of 6 multiplied by minus 2 over 5, then divided by 64 is 2 raised to the power of 6 multiplied by minus 1 over 2. Okay, so this 3 what you cancel this 3, then you'll be left with 3 raised to the power of 2 times this is going to be, since this is 32 is 2 raised to the power of 5 rather not 6, 2 raised to the power of 5. Let me write it well. This is going to be, of course, sorry, 2 raised to the power of 5. Uh, 2 raised to the power of 5. So this, remove this, right? So we are going to be having 2 raised to the power of minus 2. Then divided by, listen, 2 here 1, 2 here 3. So it's going to be 2 raised to the power of minus 3. Okay, so we have two, so you just pick one. So it's going to be 3 raised to the power of 2 multiplied by 2 raised to the power of minus 2, then minus 3. I hope you understand how we got the minus. This minus here is when we have what we have when we divide. You understand? Like when two these things are dividing each other. So you have a minus, you pick one of the base and you subtract the power. So that's subtraction. Then don't forget that this is already having a minus 3. So that's the minus 3. Then you have 3 raised to the power of 2 times 2 raised to the power of minus 2 plus 3. So this is going to be 3 raised to the power of 2 times 2 raised to the power of 1. So 3 raised to the power of 2 is 9 and 2 raised to the power of 1 is 2. So the answer is 18. So that's it. Okay. All right, let's go into another type of indices. Now, let's say that we have 9 raised to the power of 2x minus 1 is another form, and we have 81x minus 2 divided by 3x. So if you look at this very, very well, it is on that type. So when you have something like this, you notice that the ones you'll be doing, they will now have it equal to sign in between. So this is just an exponential function. This is an exponential function equation. It's very easy. First thing, you express it in index form. 9 can be 3 raised to the power of 2. But don't forget that on the power, as the power, you have 2x minus 1, which is equals to 81 can be 3 raised to the power of 4. Then as the power, you have x minus 2. Then divided by 3x. 3 raised to the power of x rather. Then you can have 3 raised to the power of 4x minus 2, which is the same as 3 raised to the power of 4x minus 8. And divided by 3 raised to the power of x. Then we have 3 raised to the power of 4x minus 2 equals to, so you see we pick one of the base, that's 3, then the power of 4x minus 8 and minus x. Then which implies that we are going to have we're going to have 3 4x minus 2 equals to 3, that's 3x minus 8. So this becomes this. Then we are going to have 4x minus 2 equals to 3x minus 8. Then what are you going to have? You are going to have 4x minus 3x equals to minus 8 plus 2. Then you have x equals to minus 6. So that is the value of x. I hope that is clear enough. All right. So let's pick another example. Let's say you have 1 over 81 x minus 2. So which is equals to 27 raised to the power of 1 minus x. Then you can, here, you have 81 is the same as 1 over, so this 81 is the same as 3 raised to the power of 4 into x minus 2. Then which is equals to 2 raised to the power of 3 into 1 minus x. All right. Then we can, so this will definitely give us, so don't forget inverse function. So this is inverse. This one is an inverse function. So it's can 3 raised to the power of minus 4 into x minus 2, and which is equals to 3 raised to the power 3. That's this is 3 raised to the power of 3 into 1 minus x. Okay, then we are going to have 3 raised to the power of minus 4x plus 8, which is equal to 3 raised to the power of 3 minus 3x. So this cancel out this. Then we'll be left with minus 4x plus 8 equals to 3 minus 3x. Then what do you simply do? You simply say minus 4x plus 3x is equals to minus 8 plus 3 by collecting the like terms. Then you have minus x is equal to minus 5. And this will this then your x is equal to 5. It's as simple as that. Okay, another example. Let's see, you have 9 raised to the power of 2x plus 3 divided by 3 raised to the power of x plus 3 equals 1. Okay, it's very easy. So we can here we can simply cross multiply. We have 9 2x plus 3 is equals to 3 raised to the power of x plus 3. So this implies that you're going to have 3 raised to the power of 2 because 9 is 3 raised to the power of 2. Then into 2x plus 3, which is equal to 3 raised to the power of x plus 3. Then this, we remove this. Then you have 4x plus 6, then which is equal to x plus 3. Then you can simply have 4x minus x, which is equal to 3 minus 6. Then you have 4x minus x is 3x, which is equal to minus 3. Therefore, x is equal to minus 1. When you divide both sides by x. Okay. Then let's take this one. Let's say that you have 9 raised to the power of 2x minus 1, then times 3 raised to the power of 2x plus 1, then which is equal to 27x plus 3. So in something like this can be 3 raised to the power of 2 into 2x minus 1, rather, minus 1, then times 3 raised to the power of 2x plus 1, is then of 3 raised to the power of 3 into x 3, then you can have 3 raised to the power of 4x minus 2, and that's 3 raised to the power of 2x plus 1, which is equal to raised to the power of 3x plus 9. So this one, they have the same base, so you can bring them together to be 3 raised to the power of 4x minus 2, then plus 2x plus 1, which is equal to 3 raised to the power of 3x plus 9. Then this, we remove this. Okay, let's put this here. Okay. Okay. So here you're going to have 4x minus 2 plus 2x plus 1, which is equal to 3x plus 9. Then you have that's is going to be 6x minus 2 plus 1, minus 2 plus 1, which is equal to 3x plus 9. Then you have 6x minus 3x, which is equal to 9 plus 2 minus 1, that's 3x equals to 11 minus 1, that is 10. Then the other side by 3. X is equal to 10 over 3. That's it. I hope it's clear enough. Let's move further. All right. Now let's see that. Okay, this one, this type of the ones we want to solve now, This is so the one we want to solve now is going to be leading us to simultaneous equation. So let's say that you have something in this form, h raised to the power of 4 minus x, which is equal to 2 raised to the power of 1 minus y. Then let's call this one equation 1, and we have 3x minus 1, which is equal to 9 raised to the power minus y. So let's call this equation 2. Okay, so let's break this one down. This equation 1 can be 8 can be 2 raised to the power of 3 into 4 minus x, which is equal to 2 raised to the power of 1 minus y. This will definitely remove this, which will give us what? That's 3. 3 times 4, that's 12 minus 3x, which is equal to 1 minus y. Okay. Then for this one, it's going to be 3 raised to the power of x minus 1 equals to 9 can be 3 raised to the power of 2, then into minus y. Then to break it down, this one will remove this one. We're going to have x minus 1 equals to minus 2y. All right, let's rearrange and it becomes simultaneous. So we can have 3x minus y, 3x minus y, then which is equals to 12 minus 1, that is 11, equation 1. And here we are going to have x plus 2y, which is equals to 1. All right. So this is simultaneous equation. So there are different ways to solve simultaneous equation. For example, I can simply make x solve a formula in equation 2 and insert it in equation 1. So if I make x a formula in equation 2, so it's going to be x equals to 1 minus 2y. So I'll call this one equation 3. Okay. Then I'll put equation 3 into equation 1. So if I do that, I'm going to have 3x minus y equals to 11. Then I can say 3 into what is x? X is 1 minus 2y, which is minus y rather, plus there's this y minus y, which is equals to 11. And I can have 3 minus 6y minus y equals to 11. So then I can have 3 minus 7y equals to 11. Then 7y equals to 11. Then 11 minus 3. Okay. Let's check something. Okay, so we have minus 7y equals to that's 8. Okay, let's see if there are no mistakes. That's 4 3x. Okay, so let's continue. Then our y will now be divided side by minus 7. That's going to be 8 divided by minus 7. Then if you get our y, then we can get our x. So x is going to be, since x is equal to 1 minus 2y from here. So let's put in the value of y. So minus 2 into so minus 8 over 7. X will now be minus, that's 1 plus 16 over 7, which is going to be 7 plus 16 over 7. 7 plus 16 is 23. 23 over 7. So that is the value of x and y. All right, guys, thank you so much for joining. I hope you enjoy tutorial. So in case you have any question, do well to drop your question in the comment section and like the video, share it. Don't forget to comment and subscribe. Thank you so much for joining us.